So let's take a look at our first example. We would like to find all the rational roots of 8x cubed plus 2x squared minus 5x plus 1 equaling 0. So the first thing we're going to do is we're going to list all the possible rational roots. So remember, our numerator is going to be all the factors of the constant term. We'll put a plus or minus out front, so it's 1. While our denominator will be all the factors of the lead coefficient. So in this case, 1, 2, 4, and 8. So that means our possible rational roots, well, the integer, of course, would be 1, and then we can simply put these all over. 1/2, 1/4, and 1/8. Now, after we've listed our possible rational roots, now we want to figure out what is the ones that work. And to do that, we use synthetic division to find the roots. So remember, in synthetic division, we put down the coefficients, 8, 2, -5, and 1. Not having everything in cubed, squared, first, nothing. So we'll try our integers first, and hopefully we get lucky. So remember, in synthetic division, we drop the 8, we multiply 2 times, then we add the column. 2 plus 8 is 10, 10, 5, 5, and the remainder is 6. So this tells us that this is not a rational root. So we'll try another one. In this case, we'll try -1. So again, it's 8, 2, -5, and 1. So we drop the 8 down. We multiply -8. We add the column for -6. We multiply, -1 times -6 is +6. We add the column, and we figure out that one of our rational roots is 0. Or excuse me, is -1. From here then, because if we go back and look, remember this would really be 8x squared minus 6x plus 1. So now we're looking to find the factors. Well, my favorite, of course, you know, is going to be the tic-tac-toe method. So we're going to multiply our 8x squared times our 1. Well, that is 8x squared. Thinking about what factors multiply to 8x squared and give us -6x, it's going to be -4 and -2. Now our factors of 8, of course we could do 1 and 8, we could do 4 and 2, but I know that 1 and 8 won't work because 8 doesn't go into either of those. So I know it's got to be a 4x and a 2x, which turns these into -1s, which means if I highlight, and let me unhighlight because that didn't work too well. If I highlight, here's one of my factors, 2x minus 1. Here's my other factor, 4x minus 1. And now I can simply set each of these equal to 0. Your key is that you want to get these down to a quadratic remainder, or quadratic quotient, because once you have it in quadratic, you can factor, you can complete the square, you can use the quadratic formula. So 2x minus 1 equals 0, x would be 1/2, x would be 1/4, and don't forget the rational 0 we found on the previous page, x equals -1. And thus, our first example is complete.